Starting with the great name of Allah, who is most merciful and beneficent, today we will talk about our final year project along my group mates, Mr. Shankar Das and Mr. Muhammad Uthman, under the supervision of Dr. Muhammad Vikas Numro and Dr. Afaq Manzoor Sharma, with the title Highly Robust Soft Stain Sensor based on Conductive Wave Fluidic Channel for the Health Monitoring and Robotics application. I'll start with the table of contents. So the outline containing introduction, aims and objective, problem statement, methodology that we have implemented, characterization of design sensor and health monitoring application and robotic application. And at the end, we will see some references. So nowadays, soft stain sensor based on capacitive, resistive, and optomechanical characteristics are in trending worldwide. And because of their important numerous application in the field of biomedical industry and the sports industry, drawing attention of the scientists and students who are working on this topic nowadays towards it. So the strain sensor is a kind of sensor which will respond whenever any kind of strain applied over it. So what was the problem or what was the reason behind our selection this particular topic for the final year project? As there was a need of an accurate and robust monitoring gadget in order to perform the gait analysis of the human body in the biomedical industry. And there was a need of accurate and sensitive and flexible monitoring and measuring gadget in the field of sports industry in order to measure their optimal range of stretches while performing exercise and in order to enhance the characteristics of already existed commercial strain sensors. As far as aims and objective are concerned, so we aim to design something with the novelty in order to design as well as with respect to conductive material. So we have proposed the different or the novel design for the sensor and we are using the novel material as well. Secondly, we want to perform the characterization of the design sensor with the aspects of electrochemical, electrical and mechanical characterization, and we want to enhance its characteristics in terms of flexibility, sensitivity and accuracy. And after the complete fabrication of the sensor, we want to implement in the applications like in health monitoring and robotics application and other useful applications for the society. So this is an overview of the methodology that we have implemented to fabricate the sensor. And number one, first of all, we have studied and searched for an optimal and the best suited material that we have used to give the shape of our proposed shape of the sensor. And then we have taken its correct proportion and mixed them together. And these are the molds, and the molds we have prepared a mold before the fabrication process, as these molds, these are the two types of the mold. One mold containing the channel and other mold is the plain mold. So these mold we have designed in SolidWorks software and then we get them 3D printed. And after the mixing of the material, we have poured this material in these two molds and we set them aside until they get the half cure. And when they get half cure, we make them combine by placing conductor between them. And in order to make it compact, we also pour some Ecoflex again on the sides of the conductor. And we set them aside until it get the fully cured. When it gets fully cured, we have prepared a composition of conductive material and then we inject it by implementing the manual method and by using two syringes at a time, one for the injection and one for the suction purpose. Here at number 9, we can see that the completely fabricate and the fill sensor with the conductive material. So this is our proposed model or our proposed channel for the sensor, that is the cyclic channel. First of all, we have designed this channel in the SolidWorks software and then we get it 3D printed. We also design other design of channel for the sensor like straight channel and the sinusoidal channel in order to make the comparative analysis, as we have proposed the cyclic channel is best as compared to other designs. So we want to prove it by making the comparative analysis. So this is the printed circuit board for the single sensor. What was the purpose of designing of printed circuit board? Because we want extra useful information from the sensor, as sensor is used to monitor the real-time data and values from the human body, and then we will get that data. In order to draw some useful information from that data, we design the printed circuit board, and for that we use the Eagle software. We design there the board layout, then we get it printed, and then we solder all components on it, and then we interface printed circuit board for single sensor with ESP32 board. Going ahead, we also designed printed circuit board for the 5 sensor. Why for the 5 sensor? Because we have designed a hand gadget for the implementation of the robotics application. So for that, we have prepared similar, by implementing the similar procedure, we also designed printed circuit board for the 5 sensor, and we interface again with the ESP32 board. Here are the material that we have used to prepare our sensor, and this is the EcoFlex. This material we have used to give the shape of the cyclic channel and to make the substrate of the channel. And this is the conductive material, and in fact it's a composition because it's a mixture of 3 different materials. So this is the first composition which we have used to fill the channel, which includes polyethylene dioxythiophene, polystyrene sulfonate ink, MOS2, and glycerin. By implementing the first composition, we get to know that it has high density and it's thicker. So we have go through so many problems while injecting into the channel because it's thicker, because of the glycerine, and not only the problem we have faced regarding the composition, but also faced regarding these conductors, because the conductor which are available in the lab was not compatible with this material EcoFlex. For that, we need the silicone coated conductor, but unfortunately, we don't have these conductor at the time. So we implement the hit and trial method, and we improve one by one. Here we can see that we have a large number of efforts and trials, and after making these trials, we get a perfect model. So after the first composition get failed, we try another composition of the conductive material, which include the P.PSS ink, DMF, and MOS2. So this was the best composition that we tried after the first composition, and it gave us best results, and it was not drying out very quickly and not making any damage in the channel. So after filling the channel with the best selected composition, we have start to perform the characterization of the sensor. And first test we have performed for the sensor was the connectivity and the resistivity test. Here we can see that we have performed the connectivity and resistivity test by using the multimeter. Here, when there was a 0% stretch, or we can see that there was a 0 strain applied, this was the condition, and these was the value that is shown by the multimeter. And similarly, as we increase the amount of strain, we get some values change in the multimeter by following this formula, because we was performing the test for the resistivity, that is R is equals to ρl upon A. So here we have increased again the amount of strain, and we get the values accordingly. So we have tried these 3 composition, and these 3 composition differ in terms of the amount of each material that we have used. As we increase the material, we get the result get better and better. So we select this composition 3 for our final sample, or the final design sensor. So after finalizing the composition, we also implement these 3 composition, all with the different amounts of all materials. We perform a test in order to prove or get satisfaction that our selected composition is best so far. So here we can see that we have select composition 3. So this is the result for composition 3, and this is the best one. So moving ahead. So these are the design. This is the straight channel, this is the sinusoidal, and this is our proposed and designed cyclic channel. So we also made these sensor with these design in order to make a comparative analysis and to prove it, our proposed and designed channel is best among these are. So here we also implement the test. We also perform the characterization with different sensor design like cyclic, straight, and sinusoidal by using that same composition 3. And here in the graph that is between strain percentage and the change in resistance percentage, we clearly can see that the best results we get with the cyclic sense. So after making comparison of the design and the composition with respect to the amount of the materials, we also perform a test for the gauge factor. Here we use the gauge, here we implement the gauge factor of all 3 different designs, and here we can clearly see that we get greater gauge factor with the cyclic sensor. So it again proving that our proposed and designed sensor is best among other 2. So after the complete fabrication and designing of the sensor, we start performing gait analysis for the different human body parts. Here, the first graph we can see it's between the time and the change in resistance. Here we can see that when there was a 0 bending, it means there was a 0 strain. So we get a straight finger, and there was some value or very less value of change in resistance, and as gradually we bend our finger at 45 degree, which means that we applied some amount of strain on the finger, and we get accordingly value of change in resistance. So what it's showing the sensitivity of our design sensor. Again, we put some more amount of strain on the finger, and accordingly the change in the length of sensor occurred, and we get value change in resistance accordingly. After the finger analysis, we also perform the wrist analysis with our design sensor. Here we can see that we perform the test for slow bending and for the fast bending, and here we can clearly see the difference, and we can also identify the sensitivity of our design sensor. As we change the movement of our wrist, quickly it changed the results in the graphical representation. So similarly, we also perform the characterization or result analysis for the knee, for the elbow, and for the knee by using our design cyclic based sensor. So after all this fabrication and application implementation of the sensor, we also develop an app, and this for the app for the purpose in order to make an easy and quick access to the gathered or monitor data by the sensor. It follow this simple procedure. First of all, we have fabricate the sensor, then we interface the sensor with the ESP32 board, and again this with the Arduino IDE, and from Arduino IDE data was stored in Firebase, and by using MIT app inverter we have designed this app, and this app will get data from Firebase stored data, and for anyone it's very easy access to the data that is collected or monitored at real-time values from the human body by using this simple app. Again, the second application of our design sensor was the soft robotic application. So here is a little flow graph or the implementation of the robotic application, that is sensor data. Collected sensor data is interfaced with the ESP32 board. Again, we use Arduino IDE in order to extract data from the ESP32 board, and by using the language Python, we instruct the now robot according to the collected data from the sensor, and we control the movement of now robot. Here we can see that the hand gadget that we have designed, and here each finger is describing its different function for the now robot in order to control the movement of the now robot. Here we can see that the little finger will perform the rolling of left arm, and the ring finger will perform the rolling for the right arm. and the middle finger will perform the left arm controlling, and index finger will perform the right arm controlling of the now robot, and thumb will be used to open and close the hand of the now robot. Here we can see individually and the clear picture of each function of each finger that is performed by using this hand gadget that we have designed by using our design sensor. So here we can see that the index finger is performing its function. That index finger was designated to move or control the left arm of the now robot, and similarly we are witnessing the same function here. So here, if we can see that this is the middle finger, and middle finger was designated to control the movement of the right arm of the now robot. So here we can clearly see. Similarly, the ring finger was designated to perform the left arm rolling of the now robot, and similar picture and that very similar function we can see and witness here. So after all these things, we will recommend some tips, or in other words, the future recommendations, because we have been through so many problems in that. The very first was we inject the fluid by using the manual method, and that was so difficult, and there was a chance of an error in the values. So we will recommend the use of autonomous machine containing the stepper motor to control the syringes while filling the channel of the sensor. And another one that we have also faced a problem while placing the conductor, because the general type of conductor that is available in the lab was not compatible with the EcoFlex. So for that we or someone must use the silicon coated conductor in order to make it more compatible. So here is the little video for our design or the fabrication sensor. Fabrication of sensor. Here we can see that how we mix the material and how we pour it for the half cure purpose. The half cure half, and this is the placement conductor. So this is pouring of Ecoplex on the sides of the conductors in order to get it fixed with the other half. So this our sensor is ready here. So these are material that we have used and how we measure them. This is mixing of the material. This is the injection of conductive material into the cyclic channel. This is the characterization phase. We start performing testing of our design sensor. This is the application. You can see that the health monitoring application here is the gait analysis of the wrist by using wristband, and this is the gait analysis of knee by using knee band. With our design sensor, you can see here. This is the hand gadget that we have developed for the soft robotic application. Here you can witness the live how we operate and control the movement of now robot by using our design hand gadget with the cyclic based channel sensor. So this is the poster that we have designed, where we can see that the sum up or the conclusion of our work that we have done so far. Here you can see that these are the application that we identify or implemented for that. These are design sensor in different applications, health monitoring and the robotics application. These are some references. So thank you so much and follow us at EE.CYU and subscribe our YouTube channel EE CYU. Thank you for watching.